Hi guys, so we are finally on learning target 2B, and this time we are solving one variable inequalities. Okay, so by the end of this learning target, you should be able to solve linear inequalities in one variable, both multi-step and compound. You should be able to represent and interpret solutions graphically on a number line, and you should be able to construct linear inequalities given constraints and in the context of real-world applications. Okay, so let's introduce these one variable inequalities. So far, we concentrated on solving equations. That's what learning target 2A was about. Okay, and remember, all solving an equation was finding values for the variable, for the letter, that made the two expressions equal. Okay, in other words, we were trying to find the value of x or y or whatever letter we had that made it true. Okay? And that's the same thing for an inequality. We can judge the truth value of a statement that is in the form of an inequality. Okay, so here I'm going to have you do some practice here. So for each inequality, I want you to state whether or not this is true. Okay, so here I'll start off this first one. Here it says 7 is greater than 3. So think about it. Is 7 greater than 3? Yes, it is, right? So that is true. Okay. So I want you to do the rest of these. Okay. Are these statements true? Okay. Okay. You should have gotten this. Okay. 0 less than 10. That is true. 9 greater than 12. Nope. It is not. False. 4 less than or equal to 4. Yep, that is true. 4 is equal to 4. Okay, 2 greater than or equal to 7. That's false. It's not greater. 3.5 less than or equal to 4.2. That is true. It is less. 256 greater than 312. That's false, right? That's not bigger. 1978 less than or equal to 2042. That is true. Okay, so consider the statement. Negative 8 is less than 4. Okay, do you think this is true or false, and why? Okay. So hopefully you know that this statement is true. Okay, right? Negative 8 is smaller than 4. Right? That is true. Negative 8 is smaller than 4. And the reason why is because negative 8 lies to the left on the number line. Right? So if you think about a number line here, that's a crooked line, right? If you think about it, on the right, we're going bigger and bigger towards positive infinity, and on the left, we're getting smaller and smaller towards negative infinity, right? If you think on a number line, if negative 8 is here, 4 is right here. Okay, all the numbers on the right are bigger, the numbers to the left are smaller. Okay, and that is why this statement is true. Okay, so if we compare any two numbers, let's say we have the letters A and B, we will say that A is greater than B is true if A lies on the right of B on the number line, right? So if this was B, in order for A to be greater than B, it would have to be on the right side. Okay, okay, so here you're going to state the truth values, so whether it's true or false for the following statements, and you're going to draw a number line to support your answer. Okay, so true or false, and prove it with a number line. Okay, so for 3 greater than negative 4, that is true because on the number line, negative 4 would be left. It's smaller, so it's less than. 3 is on the right. It is greater than. Okay, negative 5 greater than negative 3, that is false. Okay, because negative 5 is actually to the left of negative 3, so it is smaller. Okay, and then 0 greater than negative 6, that is true because 0 is to the right of negative 6. Okay. So since we can test the inequalities of numbers now, we can also test the inequality of expressions for values of variables. Okay, this is identical, this is the same to checking the truth value of an equation. Okay, so let's flip on over. Right. So here I have an inequality, right? So 3 times the quantity of x minus 2 is greater than or equal to 2x plus 1. Okay, we're going to determine if it is true or false for the following x values. Okay, so here I have x equals 10. I'm going to plug that in to where I see x. Okay. So I have 3 here. Okay, instead of saying x minus 2, I'm going to write 10 minus 2. And we're going to see, is it greater than 2x, 2 times 10, plus 1. Okay, so since we're testing the truth of this, okay, all I did was take this x equals 10, and I plugged it in wherever I saw the x, right? So I replaced it or substituted it in. Okay, so let's solve. Okay, so I'm going to do the left side first. So 3 times the quantity of 10 minus 2. Okay, 10 minus 2 is 8. 3 times 8 is 24. Okay, greater than or equal to, greater than or equal to. Okay, 2 times 10 is 20. Okay, and 20 plus 1 is 21. Okay, is 24 greater than or equal to 21? Yes, that is true. Okay, so that tells me when x is 10, that is a solution. Okay, so you're going to try it with x equals 5, x equals 1, x equals 7. Okay, plug it in and let us know what you got. Okay, so let's take a look. Okay, so here I plugged in 5 for x. Right. So I plugged in 5 for x. Okay, then I solved. Okay, and when I finally solved each side, I got 9 on the left and 11 on the right. Okay, so is 9 greater than or equal to 11? Nope, that is not true. Okay, so that's false. 9 is not greater than or equal to 11. Okay, then I did x equals 1. Okay, I plugged in 1 wherever I saw x. Okay, and when I solved it on the left side, I got negative 3. And on the right side, I got positive 3. Okay, so is negative 3 greater than or equal to 3? That is false also. It is not greater. Okay. Then the last one here, x equals 7. Okay, I plugged in 7 for x. Okay, and when I solved on the left side, I got 15. And on the right side, I got 15. Is 15 greater than or equal to 15? That is true. 15 is equal to 15. Okay. So what you can see is that unlike equations, inequalities, right, this is an inequality symbol, inequalities tend to have many values that make them true, right? And just as we can solve linear equations by using properties of expressions in equations, we can do the same for inequalities, okay? But we have to make sure we know what those properties are. So we're going to test them, okay? So here we have the inequality for less than 8. Okay, for this first part, what I'm going to do is I'm going to add 3 to both sides and see what the resulting inequality is. Okay, so I'm going to start with the original, 4 less than 8. Right? And what I'm going to do is I'm going to add 3 to both sides. Okay? Because right now this is true. So let's see, if I add 3 to both sides, what is the resulting inequality? Is it true? Okay, so 4 plus 3 is 7. Okay, 8 plus 3 is 11. Okay, let's see. So my resulting inequality is 7 less than 11. Is it true? Yes, it is still true. Okay, so what about if we subtract it? Okay, so I'm going to start here with 4 less than 8. Okay, and I'm going to subtract 4 on both sides. Okay, so here I'm subtracting 4. Let's see if this is true. Okay, so 4 minus 4 is 0. And 8 minus 4 is 4. Okay, just bringing down my less than sign. Okay, is 0 less than 4? That is true. 0 is less than 4. Okay, so far what I see is that when I add and when I subtract to both sides, the resulting inequality is still true. Okay? So what about multiplication and division? Okay, so again, let's try it with 4 less than 8. Okay, this time we're going to multiply both sides by 2. Okay, so I'm going to multiply my left by 2. I'm going to multiply my right by 2. Okay, 2 times 4 is 8. 8 times 2 is 16. Is 8 less than 16? Yes, it is. So this is still true. Okay, what about if we divide it? Okay, so starting again with 4 less than 8. Okay, this time we're going to divide by 2. Okay, and let's see if that's true. Okay. 4 divided by 2 is 2. 8 divided by 2 is 4. Is 2 less than 4? Yes, it is. Okay. So based on what we did here above, we might conclude that the truth values of inequalities are the same for those of equations, right? That as long as we do it to both sides, right, that the inequality still stays true. However, there is one huge difference between linear equations and linear inequality. Okay, so this is super important, and I want us to highlight it, right? Because this difference is big. There's one huge difference, okay, between this. Okay, so we're going to return back to our inequality 4 less than 8. Okay. Okay. But this time here, we're going to multiply both sides by negative 2. So I'm going to multiply by negative 2. I'm going to multiply by negative 2. Okay. So negative 2 times 4 is negative 8. 8 times negative 2 is negative 16. Is this true? Is negative 8 less than negative 16? No, it is not. It is false. Gasp, right? So what about here? Okay, so if we divide both sides, this time by negative 2, let's see if it's true. Okay, so we're going to divide by negative 2. Divide by negative 2. Okay, so 4 divided by negative 2 is negative 2. 8 divided by negative 2 is negative 4. Is negative 2 less than negative 4? Nope. So that is also false. Okay. So based on all 6 of these examples now, and especially these 2, what we realize is that while the addition and subtraction property is still true, right? If we add or subtract to the same side, our inequality still stays the same. What we realize is that for multiplication and division, okay, if it is a positive number, then it is still the same, okay? But if it is a negative number, what it ends up being is it flips our inequality sign, okay? So here, we're going to start by solving the inequality. So given the linear inequality, 4x minus 3 is greater than or equal to 5, we're going to do the following. First, we're going to solve it, okay, by applying properties of inequalities. Okay. Then we're going to write 5 numbers that make the final solution true, and we're going to plot them, and then we're going to graph all of the solutions. Okay, so solving the inequality by applying properties. Okay, so let's write the original. We have 4x minus 3 greater than or equal to 5. Okay, so some of us have still been having trouble figuring out what side is which. Okay, so I'm just going to put this line here so that way we know what is on what side. Okay, so to solve inequalities, we do the same thing as when we're solving an equation, right? So we think, what is on the same side of x? Okay, it is being multiplied by 4. And it is being subtracted by 3. So what do? We do the opposite. So to get rid of this minus 3, I'm going to add 3. What I do to one side, I do to the other. Okay. So this cancels, leaving me with 4x. Cancels, greater than or equal to, still stays there. 5 plus 3 is 8. Okay. So same as an equation, it's just now it's an inequality symbol. Okay. Then, to get rid of that 4 times x, I'm going to do the opposite by dividing by 4. Okay. This cancels, leaving me with 1x greater than or equal to 8 divided by 4 is 2. Okay, so this is my answer. X is greater than or equal to 2. Okay, so let's think about it. What are 5 numbers that make this true. What numbers are greater than or equal to 2? So you can pick any numbers. So I'm going to pick 3, right? That's greater than 2. I'm going to pick 5. I'm going to pick 6. I'm going to pick, let's do a decimal. Let's pick 7.5, right? That's still greater than 2. And let's do 9. Okay? So now we can graph all of the solutions. Okay? You learned how to graph this on a number line. Okay? So x greater than or equal to 2. Okay? So that's a closed circle, right? Because of equal to. And since it's x greater than 2, it's going to go to the right, where all my numbers are greater than. Okay? And what you should notice, all of these numbers lie in this shaded area, right? So 3 is right here. It's part of the solution set. 5 is right here. 6 is here, part of the shaded. 7.5 is right here. And 9 is right here. As you can see, all of these numbers are on my solution set. And technically, everything in here in between going towards infinity will also be part of my solution. Okay? So now let's try the next one. Okay? So we're going to do 8 minus 2x greater than 16. Okay? So I'm going to start by writing my original. Okay. And again, some of us are having trouble with what's on what side, so I put a line in between. It really helps. Okay, for me to remember what's on what side. Okay, so let's solve. Okay, so what's happening on the side of x? First, it is being added. 8 is being added to it, because this is a positive 8, so this is adding 8. And it is being multiplied by a negative 2. Okay, so what I'm going to do is I'm going to get rid of that plus 8 by subtracting 8. This becomes 0. I have negative 2x greater than 8. Okay. Then, to get rid of this negative 2 times x, I need to do the opposite. I need to divide. Okay. This cancels to be positive 1x. 8 divided by 2 is negative 4. And remember, this is the special thing about inequalities. Whenever you multiply or divide by a negative number, you flip the inequality. So instead of greater than, it is now going to be less than. Okay? So that's my answer. X is less than negative 4. Okay, so let's just write a note to ourselves because maybe we're going to forget. Okay, so let's star this. Okay. When we multiply or divide by a negative number, flip the inequality symbol or inequality sign. Flip the inequality symbol. Right? So we saw this here, right? This greater than turned into less than. Okay? So let's pick a number that is true. Okay, so let's pick a number that's smaller than negative 4. Okay, so I'm going to pick negative 5, and I'm going to plug it in. Okay, so let's see, what about if x is negative 5? Okay, so I'm going to plug it back into my original to see if this is true. Okay, so I replace the x with a negative 5. Okay. So negative 2 times negative 5 is positive 10. So this becomes 8 plus 10. 8 plus 10 is 18. Is 18 greater than 16? Yes, it is. So it checks out, right? Okay, then I'm just going to graph my answer. Okay, so x less than negative 4. Okay, here is negative 4 on my number line. I did an open circle, right, because there is no equal to. Okay, it doesn't include negative 4. Okay, and since I want, oh, I graphed it wrong. Sorry, this is negative 6 here. Psh. Okay, sorry, here's negative 4, right? 0, negative 1, negative 2, negative 3, negative 4. Okay, and I want less than, so that's to the left. Less than is to the left. Okay, right? So let's be careful how we graph it, right? You saw that I just made a mistake. So here is negative 4. We want everything less than negative 4. That's right here. And you can see here that the answer I checked, x equals negative 5, is part of that shaded solution. Okay, so now here's example 3. Okay, it's getting a little harder, right? But it's the exact same thing as when we're solving an equation. The only thing we need to remember is that if we multiply or divide by a negative number, we flip the inequality symbol. Everything other than that is the same. Okay, so when we solve, remember, we start by distributing and combining like terms. Okay, so this one seems a little bit more complicated, so super important. I'm going to put my little symbol. So that way I know this is the left side, this is the right side. Okay, so let's start by distributing. Okay, so here I have 8 times x, so that's 8x. 8 times negative 2 is negative 16. Okay. And then here I also have a distribution. Okay. So negative 3 times 2x is negative 6x. Negative 3 times 1 is negative 3. Okay. And then since I didn't multiply or divide by a negative, my inequality stays the same. Okay. 7x plus 4. Okay, and here I have another distributive. Okay, so negative 3 times x is negative 3x. Negative 3 times 1 is negative 3. Okay, so first step, same thing as with my equation, I use the distributive property. Okay, then now I am going to combine like terms. So what are my like terms? Okay, on the left here, I have 8x and negative 6x. Okay, and I also have negative 16 and negative 3 on the left side. Okay, so I need to combine those. So 8x minus 6x gives me 2x. Negative 16 minus 3 gives me a negative 19. Okay. I didn't multiply or divide by a negative number, so it stays as a less than or equal to. Now let's look at the right side. What do we have to combine? Okay, so 7x and negative 3x are like terms. Okay, and 4 and negative 3 are like terms. Okay, so 7x minus 3x gives me 4x, and 4 minus 3 gives me a positive 1. Okay. So here we see our like terms. Okay, you can only combine, right, when you're combining like terms, you can only combine things that are on the same side. Okay, so that's why it's important. That's why I do that pink line, so we know what's on the same side as each other. Okay. After that, okay, same thing like when we solve equations. I'm going to move it all to one side. Okay, I like to move it, especially for inequalities, all to the left side. So I'm going to actually move this 4x by subtracting 4x. Okay, so 2x minus 4x is negative 2x minus 19, less than or equal to, that canceled out, 1. Right. Then I'm going to move this negative 19 to the other side by adding 19. Okay, gotta extend my pink line. It's getting further. Okay. This cancels out, leaves me with a negative 2x less than or equal to 1 plus 19 is 20. Okay. Last thing I have to do is get rid of this negative 2 times x by dividing by negative 2. Okay. So here, negative 2, this negative 2 cancels to be 1x. 20 divided by negative 2 is negative 10. And because I divided by a negative number, okay, this less than or equal to now flips to be greater than or equal to. Okay, so here's my answer. X is greater than or equal to negative 10. Okay, and if I were to graph it, here's my graph, negative 10. Because of that equal to, that means negative 10 is included. So I'm going to do a closed circle. And all the numbers that are greater than negative 10 is to the right. Okay. And the reason why I like to do the x on the left is because if it is, then you can go according to where this arrow is pointing. Okay, but it only works if x is on the left side. Okay, so we're going to try 2 more examples. Okay. And that'll be it for today. Okay. So same thing as usual, we are going to start by distributing here. Okay. So here, I'm going to start by distributing. Okay. So negative 3 times 2x gives me negative 6x. Negative 3 times negative 5 gives me a positive 15, right? Greater than negative 6x plus 9. Okay. Then I'm going to move my variables to the same side. So I like moving it to the left, like I told you. So I'm going to move this minus 6x to the other side by adding 6x. Okay. Negative 6x plus 6x, that means 0x, so no more x's, leaves me just with 15. Negative 6x plus 6x is 0x, so that's nothing, leaves me with a positive 9. Okay, is 15 greater than 9? Okay, what you should realize is that is true. It is always going to be true. So just like our equations, when we arrive at something like this, where we have a true statement, our answer is going to be all real numbers. Okay? And what that means is that whatever I choose to plug in for x, any number I pick to substitute in for x, this end statement is going to be true. Whatever I plug in, this side is going to be greater than this side. Okay? And so that's why it's all real numbers. Okay, so let's try the next one. Okay? So again, I'm going to start by distributing. Okay, so that means the left side stays the same. Okay, so distribute. 2 times 2x is 4x. 2 times negative 3 is negative 6. Okay. Then I'm going to move all of my variables to one side. I told you I like to do it to the left. Okay, so I'm going to move this by subtracting 4x. All right. So 4x minus 4x ends up being 0x, so that cancels to be negative 5, less than. 4x minus 4x cancels to be 0x, leaving me with negative 6. Okay, what you should see here, negative 5 less than negative 6 is a false statement, right? This is never true. This is false. Okay? And when we arrive at a false statement like this, just like our equations when we arrived at something crazy like 2 equals 5, right? This tells us that there is no solution. Okay? And what that means is no matter what number we choose, if we plug it in, it will always be false. Okay? We cannot get something where it will work out. Okay? So that's why it is no solution. Okay? That's it for today. Have a great day, guys. Bye.